chyba.
All right, everybody, welcome. Good to see you. AWS user group 62nd, I think. 62nd, 64 meeting.
I think. It's even number. Well,
yeah, 10 years, buddy. I was checking recently. It's like almost 10 years. The AWS user group is existing in Krakow. Up and downs, like we're saying. The COVID in meantime were our neighbors. So a lot happened over those years. But here we are in the place called Barka. So we are on the boat. If anybody traveling, don't worry. We are streamed, so in the car you can watch it, and when you come here as well. The weather is marvelous, and I'm very thankful that you are here as well on site. And how are we going to go, Muddy?
Yeah, I think, well, we need to do some advertisements, and then, well, and then we can start.
Yeah, so first of all, I think we should introduce our partner. It's a year-lasting cooperation between AWS User Group Krakow and PMI Hub in Krakow as well. So thank you very much. As our main partner, you help us to grow, you help us to sustain our operations here, and yeah, thank you from perspective of community for the support. So today, could you enter on the stage? Present a little bit about it?
Yeah, I will give you my mic.
Yeah,
actually it works.
Oh, well, that's perfect.
Fix it in the meantime. Okay, let's see.
All right. So yeah, I think we can start our first presentation. Welcome on the stage. And again, thanks a lot for joining and for taking this opportunity to being a partner and yeah, having this talk.
Thank you very much. Thanks for introduction. Thank you as well for this cooperation. Indeed, it's a year now. I think there was quite a few events where we were able to present various interesting topics as well as learn from the other presenters. So it's nice to be here. Welcome everyone here in the boat and online. My name is Adam Dorobis. I'm from the Philip Morris International IT Hub in Krakow, and together with me today, Vlad.
Yes, hello, I'm Vlad Spiridonov, and also from Philip Morris IT Hub. And today we are going to talk about the migration of critical systems, SAP in cloud. Okay? So I guess more details will come soon. Adam, and let's start, I guess.
Okay, so a bit of like what are we going to talk about today? Short intro about ourselves and the company. Just to give you a hand, let's say an intro, what are we talking about? What's the animal? And why? Why are we doing that? Why would you move SAP systems to AWS? And then a bit, I think, how the journey looked like, what were and then the end of the day, what we have learned, what maybe we should have done differently, or some attention points that you need to watch out when doing this type of migration. And I think we have quite enough time for Q&A. So about ourselves, I'm managing a cloud transformation team. Over the last 2.5 years, I've been focusing on moving our SAP workloads from on-prem to the cloud. Before that, yeah, SAP was quite a big part of my professional experience, like over 20 years in the company, but also some other roles, not necessarily all linked to SAP. The last, let's say, 5 years, really focusing on the cloud. And now as the key elements are moved, we are looking at, okay, how can we really transform them into more cloud native, modernize those applications so that we can benefit much more from the cloud computing.
I'm Vlad, as I already told, Vlad Spiridonov. Last 2.5 years, I was in the team of Adam's teams, and together we were trying to migrate SAP as smooth as possible. So in the company, I also about a bit more than 20 years, and I was in different domains. It's commercial systems, customer care also. It was for several years, and last 4 years I was in SAP domain. So and now I switched to the critical programs in IT. So this is what about me.
Okay, and you can take the QR codes and connect to us on the LinkedIn. If you have any further questions later on or would like to connect, feel free, more than welcome. I have one question to the audience. SAP is quite a specific topic, I must say. How many of you, if you could raise a hand, have SAP expertise, experience? Okay, not that many actually. I was a bit expecting more. And AWS, I guess, much more. Okay, everyone. So good. So you will be not challenging us so much on SAP, but more on the AWS part of it. Great. Sorry? Just trying. Okay. Okay. So now, yeah. Quite a few faces, I think, know a bit about the Philip Morris International and the IT hub that we are representing here in Krakow. I just don't want to say a lot here, but yeah, it's quite a large company with 70,000 people around the world. And I think as we have now been taking the big step on transforming from the traditional tobacco, cigarettes, smoking into the smoke-free world, which you might think is a big step. I think we do think is a big step. It's not an easy one, and also as we are transforming into more consumer focus rather than the wholesale type of distribution as we did in the past, it also required quite a lot of technology shift. So you need to connect to the consumers much closer. So the IT became much more important for the company compared to the previous years, and I see that over 20 years experience how much that's been transforming, and that definitely is accelerating in the past. IT hub in Krakow is like over 300 people now. 9 major departments with various things from the cloud computing through the big data, cloud operations, but also things like UX, design thinking teams, etc. A lot of nationalities, over 20. I think we're quite proud to really have a very diverse team of experts here. So you can actually connect us through this QR code on the banner as well, in case you are interested of what are the opportunities in our teams. And now to the essence of what we wanted to talk to you about here. A bit of a just overview. It's not like a very complex graph, but just to tell you what we are talking about. So it's really like the enterprise landscape of SAP solutions. As maybe you see, it's the most of the systems are ECC 6.0, so this is not the latest technologies from SAP, although they are still in the mainstream maintenance, so they are absolutely up to date, but not really latest in-memory computing, etc. There are some systems which are already in that coming from the latest technology stack of SAP, but majority is not. Which is actually quite important if you think about moving it to cloud computing environment. The key, of course, is the ERP with the 4 regional instances, as you can see. So we have one for EU, let's say, so it's the core Europe. Also the operations center, so the headquarters are managed in that system. Also, it's the largest and most complex. And then we have the Americas one, mostly for the Latin America or South America and Canada. Another one for Asia, and last but not least, Eastern Europe, with just a few countries, the smallest of those. On top of that, we have quite heavily customized master data solution, which is still the ERP system, but serving as the master data source for all the other environments, and not only SAP, but actually any system in PMI. It's also managing the identity of the users, so provisioning accesses and then credentials, etc., to all the systems in PMI. That's actually evolving and switching to the more cloud-native solution, more or less, as we speak. And the last but not least of those central systems, the HR solution, which is the SAP HCM solution. Quite a big one because it serves all the employees and all the entities worldwide. And there is a number of other smaller systems, sometimes a bit legacy, sometimes acting for some specific purpose, all managed with a solution manager. That's probably the most modern one in the whole landscape because we keep it really up to date. So it's all the in-memory computing inside and all the components that actually SAP has in their portfolio. Usually you can find it as well in that single solution. And what is important, especially for such an enterprise environment, is there's a lot of integrations with the outside world. For that, the core system that we are using is the SAP PIPO, so the process integration, process orchestration solution, which we use as a core integration environment for SAP workloads, but it connects to anything else outside of this SAP environment. On top of that, yeah, as you can imagine, this landscape, the first deployments were back in 2004, if I remember correctly, the first go-lives. So it's quite an old one, so there's a lot of legacy. A lot of integrations are happening through the file transfers, which was a bit of a headache as well when you start moving this type of workloads to the cloud. For the file transfer, we mostly use the MoveIT solution, which is like connecting those environments to the rest of the portfolio. And then we also started to use MuleSoft for the API related connectivity and integrations, mostly for some cloud, newly developed, newly implemented cloud solutions. So that's just to give you a bit of an overview of what type of solutions we are talking about. A few metrics, not necessarily to impress you, because I guess there are many enterprises which probably beat those numbers heavily, but just to get a bit of more numbers behind what we were dealing with. So we have 38 system landscapes that we have migrated. Throughout the project, we were also able to decommission some and to kind of offset them. So there were a few more, but we luckily were able to not to move them. Landscapes, we mean like a production instance with all the non-prod environments that are surrounding it. Out of those 38, 7 are enterprise critical. So those are mostly the ones that I've shown in the middle of this previous slide. So the ERP, the HCM, the HR solution, the SAP PI, which is like a core component for integration, and the master data. So those systems are enterprise critical. So as you can imagine, it's a bit of attention from both IT management as well as the business stakeholders when you start touching them. So usually you say, we don't touch these environments in any major exercises. We ended up migrating to AWS over 1.2 petabyte of data. So that's quite a lot of data that you need to transfer from one place to another. We ended up with like almost 500 EC2 instances for this entire landscape. And that landscape serves over 25,000 end users. And quite an important aspect, and actually, as you will see later on, the number of interfaces that systems are connected to is like over 20,000. Actually, I don't really have a good total count because that count never ends. But I think for the core one, like this European instance, we have counted over 10,000 just for the single instance. So you can imagine that, yeah, moving that from one place to another is not an easy task. Okay, why? Why would you move that to AWS if it works well? On-prem, actually, it was really pretty stable. No major incidents. I think the last one, like a really big one, was back, 11 years ago. So I think since then, we really managed to keep it in a very stable situation, keep it up to date as well. So over the years, we were able to come up with a strategy also to patch it regularly, to have the support packs from SAP installed regularly. So that was pretty in a good shape. But, you know, for some of you who have maybe attended some of the previous meetups, yeah, PMI has came up with a strategy of really cloud first, and that strategy was really driving also some other decisions that we have made. One of the key ones, and actually which was driving the cloud migration program, was that we decided to close our own data centers. And you know, this one data center was rented, so the contract for rental was just cancelled. The other one was owned by PMI. It was sold. So as you can imagine, there is a deadline. You know, the owner of the rented one wants to get it back, and the one that is buying your data center also wants to get it at some point in time. So we had that hard stop, and the hard stop was end of last year. We still had a bit of a contingency there, so actually we have completed the whole migration in March this year. Now, as you can see on the right-hand side, it's not just moving to AWS. In the meantime, and I think Piotr, that is here, will be able to share with you much more details about the platform that we've built on AWS, which we call DEEP, Digital Engineering Enterprise Platform, which is like a landing page or a landing zone for all the workloads that you can get from AWS, being in PMI, but it's also about various components that we have built as a ready-to-use services with like a self-service consuming, but they are also coming up with the properly hardened infrastructure, operating systems, and all the components that are part of it. But yeah, I'm not an expert in that domain. I think you can also look at one of the previous meetups recording. Then I think Piotr was sharing quite a lot of details about that. Now, yeah, once moving to AWS, you would try to expect, or you would expect that you get some benefits out of it as well, not just because you have this company strategy or you know, shutting down the data centers. This obviously was the key driver. But yes, definitely wanted to also gain some benefits, improve the system operations. Some of the aspects of that are, you know, every workload that we are deploying on AWS is infrastructure as a code. So for that, we use the Terraform. That includes all SAP workloads. So any instance that you bring up is not done manually, but really scripted with the Terraform. Application deployment and configuration deployment automation via the Ansible AWS. And there were also a couple of other things which we did not have on-prem, but by moving to AWS, we were able to achieve at the same time. So for example, we introduced the cross-account backup strategy, which was a key element of our response to the ransomware type of attacks, so that you can actually put your backups in a very isolated environment in case of this type of threats. And probably a few more, but I would say a bit, SAP is a bit strange animal here. I will share later on what type of, you know, limitations you have when you deal with SAP on the cloud. Okay, so how would you approach that? What we did is, first of all, there was a lot of, I would say, doubts. Can you really run those systems on the cloud, on all virtual environments? Before the migration, still the central database services were dedicated hardware These were not virtualized systems for databases. For us, majority of the landscape is Microsoft SQL. So that was one of the changing factors that we needed to take into account. So we basically decided to run a POC, taken one of our most complex systems, and just try to put it on AWS and see, does it run? Are there any major problems with that? And we use that POC also to define the architecture, how the landscape should look like, finalize all the designs, go through a lot of discussions with our enterprise architects and the overall architecture community to get it approved, so that later on we could reuse it for much faster migrations to AWS, as we had overall we had 2 years for the execution. Once we have done that POC and we more or less were feeling comfortable with that, then we have defined, okay, so let's maybe not go directly and jump into kind of a big bang migrations. Let's take one of the most complex systems again as a pilot. Actually, it was the same landscape as for the proof of concept, but now for real. So to start migrating the systems. So yeah, we first had to identify that landscape, agree the deadlines, go live dates with the business, and then really define how we are going to do that. What will be the migration approach, how we would do that, evaluate the effort, define the testing strategy, and so on and so on. And we ended up, that was actually taking us a longer time than we expected. So here we have still found quite a few surprises, especially in the area of the integration, in terms of the limitations that SAP has, but also things that were changing with between the environment on-prem and the cloud. PMI basically, before we have started the cloud transformation program, was a flat network. So from any place in the PMI network, you could reach any, more or less, any endpoint in the data centers, etc. So basically communication between the systems or between the users, and the system was not so much restricted. Anybody could reach to anything. Of course, there were other authorizations behind, etc. But in terms of the networking, it was all possible. But with that, more or less at the same time, we had said, okay, that's not really a good practice. We need to switch to the more segmented network, and for SAP and this number of integrations, that was a pain point. That was really a painful exercise to define all the firewall rules, all the routing between the various subnets, between the various VPCs, etc. And still, although our strategy is cloud first, and we were shutting down the data centers, apart from the two major data centers, we have a lot of computer rooms in the factories, in some offices. So you also needed to make sure that you have still the connectivity between all those locations and this migrated SAP systems in the cloud. So yeah, at the end of the day, we have migrated that system in line with the timeline without actually any issues after go live. So that was really, really a successful one. And I think that was quite important because that was quite at the beginning of this whole cloud transformation journey, where we didn't yet migrate a lot of solutions to AWS. And that was a bit as well a relief to the senior stakeholders, where they say, okay, if you can do that smoothly for that SAP systems, probably those less critical and less complex ones, that's peanuts. So we really now trust you guys, and we can really go full speed. So that was quite important to do that smoothly. And I think also it was important because actually initially we wanted to do that in Q1. We were quite ambitious. At the time we said, okay, 3 months, and you can, end of March or April, really go live. But then we said, okay, let's really take a step back, do that more carefully, and to make sure that we are really confident that there will be no issues. And that paid off because later on it was really much easier to address the rest of the landscape. And then, yes, the execution, which was planned till end of last year, we had a bit of delay, which I will tell you why in a moment. Okay, so basically, just to wrap up the how, it was about discovering all the components that you have of the landscape itself, of the integrations. The integrations was key. Then defining really the target architecture, and that simplifies a lot in terms of deploying it later on. So you really have a catalog of the architecture patterns, to which we more or less mapped most of the systems. There were maybe a couple of exceptions, like this. If you have a system that is fully in-memory computing, then maybe you need to do something specific for that. But other than that, we were able to really have that fully there. Then you run the non-functional tests, backup restore. That's another area which is changing compared to when you have it on-prem. On-prem, you have a different infrastructure for managing the backups. So yeah, that's something that on AWS will look differently. So it's good to test it, that it really works. Continuity. So we have a setup where we have the hot standby system, but not a high availability environment. But it's again different way of log shipping, from the database, primary database to the standby. So you need to make sure that again it works and that you can check it, and also test your failover to that continuity solution. And yeah, performance tests, and that was actually one of the key, let's say, attention points from the many stakeholders. SAP, as you can imagine, is 25,000 users, and they do spend a lot of time working in that environment. If suddenly a transaction takes 2 seconds in terms of 1 second that it was before, it might become a problem. So we wanted to make sure that there will be no negative impact on AWS. I don't have a dedicated slide on that, but there are interesting things related to performance. We were also looking at some other companies, what was the experience, checking also with SAP, what are the best practices, because one thing was for sure, the latency between the existing compared to the on-prem system will increase when you move it from the close to the end users data center, which you have in worst case 70 kilometers away, at least in the headquarters in Switzerland. If you now suddenly move it to Ireland, yeah, you will have some latency increase. So, and SAP actually is quite sensitive to the latency, especially the SAP GUI environment, the FAT client. But then you can offset that by other gains that you can get when deploying on AWS. So at the end of the day, for most of the systems, we're actually able to improve the performance rather than having any negative impact. But there were also a few surprises which we did not get that expected benefit. And then user acceptance testing, Vlad will cover that, so I will not talk about that a lot. But as SAP and especially the ERP solutions, they are in a big corporation, especially if you are US, listed on the US stock exchange, you are under the SOX regime, which is putting a lot of controls on top of what you are doing. So there are certain processes that you need to follow to make sure that you are bulletproof in front of the audits, that all the controls also work seamlessly after migration. There are a lot of controls which are IT specific. Of course, there are business ones as well. But yeah, IT environment changes. So some of the controls are related to the backup restore or your change management process, etc. So you have to make sure that it actually works seamlessly afterwards. Also, the systems are validated from the computer system validation perspective. So the GXP validated systems. So you also need to make sure that this part of the equation is working well. And of course, last but not least, making sure that from the business perspective it works and the business signs off, which is part of the change management process that we need to follow. And then important aspect is to really dry run your cutover plan to really make sure that actually it works as expected. And then you will have learnings. There will be things that maybe during the dry run you will figure out is not working very well. So you need to maybe address something. Another aspect which is important is also to manage your downtime, agreed downtime window. And that's you can only validate that in a dry run of that cutover plan, so you can really be sure that you will not exceed that window for the downtime, for the go live. And yes, go live with contingencies. That was actually lessons learned already from some previous projects, where it was actually very good practice to agree with the business well in advance the go live dates, but also agree with them what are the contingency go live dates in case something doesn't work on the original one. Because if you miss that go live date and you have no plan B, business might tell you, yeah, but now it's over, right? We don't have another window of opportunity to migrate that big system. So it's good to really have that pre-agreed, so the business can expect something coming in case something goes wrong. We actually didn't have to use it, but yeah, something good to have in place. Okay, the team, a few words. Actually, the team was pretty big. From the PMI perspective, internal, not that much. We have just, actually, it was Vlad, me, and one more guy. No, sorry, the architect. So more or less we were 4 of PMI employees that were dedicated to that SAP migration. Of course, there were many other people, like service managers, the business owners, the SMEs, the subject matter experts who actually were knowing what's really in that system, so that the moment you discuss some integration aspects with other solutions, you have those experts who still have knowledge. The knowledge is a challenge. If you have an environment that is over 20 years old, yeah, you probably have lost that on the way to a big extent. Also your partners. For us, the partner is for many years already IBM in that environment. Luckily, we actually had some names there who are with us for a long time, including actually one of the key project managers from IBM side who actually worked in that environment for many years before. And then, of course, at the end of the day, you have the team who is doing the job, doing the migration, scripting the Terraform scripts or Ansible scripts, making sure that everything is in place, and then executing the whole cutover plan. And that's a lot of people from various angles, both the SAP experts, the infrastructure experts, the integration from all various technologies. Usually these are different teams, different skill set, different knowledge. And then on top of that, you have some more ad hoc support from the InfoSec teams, networking, and the business, last but not least, business users who need to execute and sign off the user acceptance testing. Okay, and with that, I will hand over to Vlad to cover.
Okay, thank you.
Next part.
I also would like to tell a couple of words about our team. The team was amazing. I need to admit it, because our guys who were in offshore in India and who are here with us, they did a very amazing job, I would say. And I would like to give kudos to people who are connecting through the YouTube. So guys, if you are with us, so thank you very much. Now, Adam explained how we migrated our SIP to Amazon, but I would like to tell you a couple of words about what is the main difference, or what is the main challenge to migrate SIP to Amazon. First of all, for business, it means nothing. I need to say that again, we repeat it as a mantra. We do not bring any kind of functional changes. And can you imagine that we come to the business with the point that we would like to do downtime, we would like to down the most critical systems for nothing, actually, for them, yeah? And here, mainly the biggest point for us, main challenge is to get a buy-in, yeah? We need to explain them why we need to do it and why we need to we need to suffer for a couple of days, and what is the main idea behind it. And I assure you, this is the main challenge for everyone, yeah? Because again, we do not bring any kind of functional changes. We do lift and shift. And as soon as we understand this, and as soon as we realize that this is the main challenge, then the next challenge will be to secure the go-live date. Yeah, because again, it depends on the business processes. We were trying to find the right dates, just to avoid any kind of problems with the business processes, because you know that SAP has several critical business processes, like monthly closing activities, quarterly closing activities, yearly closing activities. So all these activities should not be somehow broken by our project stuff, I would say. And that was a very, very complicated point to, I would say, to agree with these dates. Yeah. And the most important and difficult points, not just agree with these deadlines, but also to keep these deadlines. Because I am assure you, so you can draw a very beautiful Gantt chart, whatever, and everybody will be okay from the very beginning. But several weeks before the go live, business can come to you with the question, you know what, we have very important and very secret and very whatever projects, and we have to, let's say, postpone the go live. And here we were quite good, I would say, because we managed to keep our original almost always. Yeah, so we postponed our migration twice, yeah, because of the business requirements. But again, it was just twice, yeah, because we were quite strong to protect our go live states. That was very, very important. So what is very important to say here as well, yeah? Why it's important? Because we were trying to avoid a domino effect. Yeah? Because if you have a problem, you have go lives one after another one. Postponing one means that you have to prolong your program automatically, and you know that prolongation of the program, it means that you have to do something with the budget, with the time, and with everything. Okay, I'll take this one. So no problem.
Yeah, the mic is fine. It's just the video. If you can stand a bit, yes, or on the right side, then everyone can see you on YouTube as well.
Okay, you can stay. Okay.
Yeah. Thank you.
Okay. Now you know that this is the right place for the presenter. Yeah. Okay. Good. Okay, so this one is, we discussed two first bullet points, and the second one is regarding the migration of key environment. Here it's also important because before that you have had all your environments in the same ecosystem. Yeah, so it was on-prem, and the migration of the environments were more or less clear how it goes. But as soon as you migrated key environment, so you already have a difference. Yeah, because your key environment is already on AWS, and your production is on prem. And here it's the main difference, because when you migrated QA environment, you actually need several weeks to establish all connection, all integrations. To do that, to let production environment be migrated within a couple of days. Yeah, because you need to establish the right rules, you need to establish their patterns one after another one. So, and this is the problem, yeah, because you've got a QA environment migrated to AWS, but in fact, you can have a problem with the current project that you have now, yeah, because you have a lot of project managers who are doing the very critical, important projects, and they will be running circles around you with the questions, where is my integration, guys? So what did you do? So the problems can start already from the QA environment migrations. So that is why you have to pay attention for that. You need to talk to your project managers in advance, and you need to make prioritization of these connections, yeah, of these integrations. You should know what kind of integrations, patterns, whatever you need to have from the day one. Okay, next one. To keep updated all your stakeholders. Actually, two bullet points there together. So again, this project is about making friends, I would say. If you do not have friends who can support you, so it's much better, let's say, to spend enough time to make friends, or at least to have people neutral for these projects. So you need to have people who knows what is going on. You need to try, let's say, call down people from the very beginning. So, and this is about the communication. Yeah, you need to know to whom to talk to, and you need to know what to talk to, what kind of message you need to cross. It's obvious. Yeah, I'm pretty sure that you did hundreds of projects. But in such kind of critical project, very political project, very complicated project, this is the point number one. Yeah. Then establish clear communications we already discussed, and to document all integration, because for us it's again the ERP system for Philip Morris company, it's a huge one. Yeah. So and we are audited from left, right, and center. For example, during this 2 years program, we had 2 audits from PricewaterhouseCoopers for 2 instances that we migrated. So, and by the way, we've got green reports, which is very good. And just to be sure that you documented all your steps, critical steps, according to the your cutover plan, and it's done properly with the good quality pictures, screenshots, with the timestamps, everything should be there. So again, it's very important, at least it was important for us, and we recommend you to think about this. One bullet point, it's not mentioned here, but I would say it's also important to say to you. So as soon as you make a decision, go. So, and you started to migrate it, you migrated the database and you started to switch on the integration in production. So here, there is no any kind of rollback. Yeah, so if you started migrated and if you started to open the connections, actually you are not able to migrate back, rollback, to make any kind of rollback scenarios for SAP because of the complexity of the integration. Also, it should be keeping in mind, and also we need to, you need to cross this message to the business. That, guys, if something happened during the downtime, so they need to fix it, and that's it. So that is why you have to have all people around, and you have to agree with the business with the clear downtime. Actually, we agreed about this downtime plus some contingency hours. This is very important, guys. Yeah, I guess we can go to the next slide. Yeah, sorry. Yes. And how to do it. Yeah, I don't want to go through all this table because, you know, this is quite, let's say, familiar exercise about stakeholders mapping. But for us, it was very important to define to whom to talk to. Because, again, we don't bring any kind of functionalities, but at least we need to have friends here. And these friends, they are those groups. Yeah. And for us, it's very important. Probably, again, I'm not going to talk each single cells here, but couple of points I would like to mention here quite clearly. Yeah. So first of all, we were lucky enough to have a SAP governance board. So it's people from the business who are responsible for implementing, for approval the changes. So this is high-level people from the business, and you can talk to them. You can explain them what is going on. And we've got the full support from this sub-governance board. And this is also kind of a key successful factor because we kept them updated each single time. You have to invest the time of talking more or less the same things from different angles for different people. From time to time, it's really annoying, but it's really paid off, yeah? Because you have to talk and you have to be, let's say, ready to cross all kinds of messages that you need to cross. Yeah? And one more topic. Probably here, it's because it's clear what kind of stakeholders we have. Again, your main big friend, really big friend, it's sales manager. You need to have this very big friendship with this guy. And this person should be next to you as kind of your shadow, and this person should help you everywhere. If you do not have, let's say, support from sales manager, it could, let's say, make a very big hard time for you. Yeah. And one more topic here, also I would like to show it here. So if you have auditors, it's much better to involve them from the very beginning. Because we knew that we will be audited by PricewaterhouseCoopers. That's why we started to engage them, let's say, half of the year before our first migration. So we just established a call with them. We explained what kind of test strategy we are going to implement and how we are going to test it. Yeah? And that was quite a good move, I would say, from our side, because at least they agreed that, okay, guys, this way, from our point of view, it's reasonable. And it's already eliminated 60% of the questions why you did this like this are not like that in our audit that we had later on. So this is what we have. Again, you need to pay enough attention, you need to invest time, and you should know to whom to talk to. And communication, again, is a key here. Then, look, for me, the problem here is just to spend on the right time for discussion of this slide, because I can talk hours, but we have just 5 minutes. So this interface testing strategy, it's again, it's quite easy. Yeah. First of all, people can be scared about number of interfaces, because we are talking about tenth of thousand. For example, we have had in our migration was about 27,000 of interfaces. And you can understand that when you migrate to this number of interfaces, in each single interface, you can have a problem. When you're talking to the service managers, everything is very important for them. They would like to test everything. But can you imagine? You are not able to migrate to test 27,000 interfaces. It's impossible, yeah, because it's no way. Yeah. Then a question: how to do that? Yeah, and how to be sure that you did the right move here in terms of the testing. Actually, I would recommend you to go in this way. So first of all, you need to invest enough time to make a discovery, to understand how many interfaces you have. Yeah. So, and frankly speaking, our IBM colleagues, they did an amazing job. So we had this first version of Excel file, which consists, I don't know how many interfaces there. And then these interfaces should be grouped by their technology patterns, because your integrations have a limited number of technology that being used for the integrations. For example, all these 27,000 interfaces, they were split between 23 patterns, technology patterns. It was, as I do remember, 18 patterns for the integration through PI, and the rest it's direct integrations. So it means that you end up with the 23 groups of the interfaces, even if you have about 27,000 in total. Yeah, and then very important to understand what exactly you would like to test. Yeah, and in these patterns, in this group of patterns, you need to define the candidates for the testing. And this is the most tricky part. Yeah, because from our side, again, if you have a lot of people, service managers, each single service manager in his doc come to you with the question, I would like to test my system, which is again not possible in terms of timing, in terms of resources, in terms of everything. Then what you do, you need to define exactly the most critical systems for you in each single pattern. Yeah, so you can say that, okay, in this pattern, I would say I can limit this two systems, and that 3, and in this pattern, just 1. So having these candidates, for you, it's kind of you can be assured that if they work, it means that the rest of the systems that are in this pattern, they will work from the common sense point of view, because they use the same patterns, they use the same technology. And this message was the most critical to cross to all people, because people can ask, okay, why you did not test me? Did not test my system? It's also important, but then you have to explain that. Look, we already tested 5, and for us it's enough. Yeah, and frankly speaking, it's helped us after the first migration, because when we migrated first Latin America, and people got kind of evidences that it works, everybody started to breathe better, and they told us, okay, guys, we trust you. Okay, you please do like you told us. Okay, so you need to discover, you need to define the patterns, and in the patterns you need to define the candidates for the testing. And again, my advice: please use the very limited number of the testing of UAT, because UAT is the most expensive part of the testing. So now I need to stop, otherwise, yeah. Okay, here, the testing approach. So as you can see, again, it's not a new news for you because I'm pretty sure that you did it several times. But what I would like to tell you that actually the full testing approach, we can split between 3 big groups, which is UAT, as I already told you, it's the most expensive one. Because of involvement of the business users, because of preparation of the test plans, in terms of the documentation of this. So it really takes time. Then you have technical testing. This technical testing can be done by the, let's say, IT people or project team people. And migration validation is very important, especially for the audits. We need to confirm that the data that you pick up from the on-prem is the same as the data that you restored in the AWS, and it will be audited for sure. At least it was a special subject for audit for us. So this is a testing approach. Again, as I told you, user acceptance tests. I would really, let's say, recommend you to make it as compact as it possible, but not less. And by the end of the day, you need to make some controls to be sure that you can go live. Yeah, because you need to be sure that you did everything, even more, to get the green light to go live, and you're absolutely fine with what was done. So as you can see that here, the list of the controls that we have had before the steer-core green light. So again, this bullet point is quite clear for you. Maybe I would like to draw your attention on this point, which is BCS plan. It means that business should know what they are going to do when the system is down. So it means that in advance, you need to talk to the business. You need to explain them that it's not the first time when their system has to be maintained. Please recall your documents that you already created several, I don't know, years, months, whatever ago, and follow these documents. Yeah, and it's not easy, but actually, if it's the communication done properly, so it will work. Yeah. So I need to stop, otherwise. Okay.
Thanks a lot. So
this is the right place.
Okay. So hope this mic is okay. Okay. So I mentioned earlier that there are some limitations of SAP. So I'm back a bit to more technical topics, not only technical, but let's say AWS, SAP related. One picture is not showing. Doesn't matter. Licensing is an interesting part. As we are mostly Microsoft SQL, it turns out that there are certain license limitations. You can't run any, let's say, type of workload on for SAP specifically to be able to get the proper support from SAP and from Microsoft in case of those workloads. So we ended up with having a bring your own license model for SAP specifically. Probably there are other systems which have a very similar limitations, but you can't have the license as part of the subscription on AWS, or you can't use RDS, for example, etc. So that's an important topic. And also related to that limitation is that SAP requires you to use the certified instance types. So you can't run SAP on any hardware. In case of AWS on any instance type, you need to use those that are certified. There's a number of those which are available, so no problem with choosing from. But yeah, you have to keep that in mind. That might bring some limitation in terms of what you would like to do, in terms of bringing maybe the most optimal instance type for your workloads. So that's another limitation in that sense. Then, yeah, one of the key aspects of running workloads on the cloud would be, using the auto-scaling capabilities. And unfortunately, SAP is not a good candidate here. So it natively does not support auto-scaling. There are some ways to have auto-scaling of application servers, so to bring up and shut down application servers, but that is not really out of the box available on SAP. Actually, in the meantime, since we have started this program, AWS came up with some capabilities to actually help with that auto-scaling capabilities, but that's also limited only to, like, for example, running additional application servers and shutting them down dynamically. Other than that, you are very much limited what you can really do in that sense. So more or less, what is quite important is to scale your environments properly and maybe review that, after a while to see whether the workloads are or the instance types, the scaling of the instances is proper for your system. Also, SAP is using SAP-specific load balancing, so you can't use those load balancers that at least the ERP solutions, maybe some of the web ones with the web front ends, maybe that's a bit different, but at least for the majority of the workloads, you can't really use the AWS provided load balancers. And last but not least, from the big ones, let's say, which were really limitations for us, as you have seen before, we have a lot of integration still with the file-based integrations. So obviously, the key direction from the InfoSec was to avoid the SMB protocol and the Windows file shares. But unfortunately, SAP does not talk to S3 natively. You can't really easily move there, which has changed actually recently. I think it was announced in December, if I'm not mistaken, that you can now have an add-on that is provided by AWS that allows the ABAP to talk to S3. Anyway, that would require a functional change. You would need to adjust your code to be able to use this capability. So, which is anyway something we didn't want to do, but at least we now have the option. We can now start maybe at least some programs which we'll be touching anyway. We would then be able to get rid of the SMB protocol and switch to S3. There are probably a few others, but I just thought that those are the ones that we really faced throughout the project and had to do something specific to address those. And I think that's the... okay. And now the last one, where we wanted to share a bit of lessons learned from the whole program. What worked well, a couple of first points. It really pays off to invest time to define your architecture patterns early, even if that means that your preparation will take a bit longer. But later on, you can really make your migrations very quick. For some of the smaller systems, we were really able in a couple of weeks to migrate the entire landscape because we didn't have to go into any discussion on architecture. You had the pattern, we just applied, moved, the system was small, not many integrations, so we could do that quickly and react to some changing environment on the business side. Yeah, what already Vlad was explaining, you can't migrate this type of business critical system at any time. You need to well in advance agree the timelines. The business has to implement or let's say execute their business continuity plans. In a factory environment, they need to move goods from a storage warehouse to closer to the machines, so they don't need to do that during the downtime of the SAP systems. They need to release production orders that they will be distributed to the manufacturing execution systems, and so on and so on. There is a number of things the business has to prepare, as well as they need to be a bit ready for, let's say, unforeseen downtimes that might happen after the go live. Yeah, as Vlad explained, there's no rollback. Once you open up the system and the data flows between the SAP environment and the rest of the environment with this 10,000 of interfaces, no way you could reconcile it ever after if you would decide to roll back to your on-prem environment. So you really need to fix issues as they occur, which might mean some disruption to the business, so they need to be ready for that.
And maybe also we can say about the payments. That payment is also a special subject, and a business should be prepared that, again, some payments should be done in advance. And the rest of the payments, which can wait, should be done in 3 or 4 days after the migration, just to let systems to be stabilized.
Yeah, that's a good one. Yes, indeed. Especially if you have some critical payments like taxes, excise tax in the case of the tobacco company, that's an important one. We pay a lot of money to the tax authorities, and yeah, if you have something that is normally scheduled for Monday just after the go live, better do it on Friday, so that in case something goes wrong, you are actually on the safe side. Already Vlad explained, your tight schedule can collapse in case you need to delay a migration. For us, this was 48 hours windows for most of these big systems. And twice we had business really coming back saying, guys, we are having a stock build up that weekend, we can't shift it. This was the logistics situation that was, and the whole supply chain, which was over the previous years during pandemic collapsing. Now we have to rebuild. We have some, trucks, deliveries coming in. We can't go live that weekend. We have to postpone, and the postponing means in 3 months. So that, as you can imagine, that shifts your whole plan. You need to reshuffle, and yeah, if you have this tight schedule, you can't now say, okay, so August you had this P1 Europe, let's bring another P1. Yeah, but we are not ready. We have not even started testing, so you can't just swap easily. A couple of weeks before the go live. So that means the whole plan is really screwed up. And then yes, there are, apart from your core SAP environment, there is a number of supporting systems. In our case, the key ones were the modules system, which we use for data and document archiving. Need to make sure that it's ready for the first pilot go live already. Control-M, which we are using for job scheduling for SAP environments, and the all integration landscape, which we were migrating to the cloud as well. So SAP PI, the Move IT, the whole shared file system, etc. Yeah, and then definitely integration was the most difficult part for various reasons. Just the sheer number of integrations, but then the changing environment, switching from the slot network into the segmented network. We also were trying to remove some of the obsolete technologies where possible, like FTP. You probably, on-prem with a non-segmented network, you have an FTP. It's not good, but probably not that critical. But yeah, if you put your workload on the public cloud, you don't want to use the FTP anymore, right? So there were a couple of cases where that's something we were changing, or you wanted to make sure that you have data encryption for data in transit everywhere. So that's another aspect which in a couple of cases was a bit painful. And maybe last but not least, whatever you do to estimate your cost on AWS, you will be surprised. It will be more expensive than you thought at the beginning. And for various reasons, there will be things like, your environment actually grows, and systems like SAP ERP, they are growing quite fast. So that's one aspect. So definitely a good practice is to clean up as much as possible upfront. So that's something we have not done. Probably we should have invested some time into cleaning up some of the data and like interface folders. So, we ended up discovering during the go live when we had folders with 70,000 files. Some of them were as old like back in 2010. So yeah, these things could have been done earlier, but we simply did not discover that well enough in advance. And there actually was a bit of a pain when we started moving it to AWS. But also there are some other things like, watch out for bad practices. You discover that you have some services that are deployed but never used, like, EBS volumes that are not attached even to an instance. And, with the systems, which one of the biggest was 18 terabytes, suddenly it's important, right? You have a lot of storage that is that you have to pay for, but actually never use. So this type of things that can be actually easily avoided, but these were a bit of lessons for us as well. So to make sure that you have good practice, that actually from the very beginning, already from the project phase, somebody is really monitoring that, you put the right alerts, you use the right tools from AWS to discover that quickly. Plus, of course, educating people who are new to the AWS environment to make sure that this type of mistakes are avoided. So yeah, I think that's it from my side and from our side, and I think we are ready for answering questions.
Great, thanks for the presentation, and I will give the mic for the questions.
Thanks for presentation. First question, which came to my mind: why even think to migrate to AWS when you have your own prem, your data centers, everything?
Okay, so you must have missed that slide.
Yeah, I saw the slide that you've got a few benefits, but like, why you started even thinking? Like, what was the first?
I mean, clearly the key driver was really the company strategy to move to the cloud. And the consequence of the strategy is the decision to shut down the data centers. So simply, there is no place anymore for those workloads. Of course, we have some specific workloads which we still keep. It's something that we call like a co-location space. We are now having some smaller space rented in Switzerland, but this is clearly restricted really to some smaller solutions that really are very prone to the latency, that need to be closer to the factories, etc. But moving that there would not be less complex than moving it to AWS. So the project complexity itself would be probably equal without really any added benefit. So yeah, we just simply, that was the key reason.
Okay, thanks.
Thank you. I think there's another one here.
I have a question to Vlad, because you mentioned that one of the first and biggest challenges was to get the buy-in from the business, as it doesn't bring the immediate functional value for them. So are you able to reveal the secret? How did you do it? How did you convince the business? How did you buy them in?
Look, I don't have a silver bullet here right now, because it was a series of conversation with high-level stakeholders. Yeah, so first of all, we agreed that what was explained by Adam, this message was crossed not through Adam or me to the business, yeah, but it was done from the high-level people, and they agreed with this approach, yeah, because they should understand, I don't know, from CIO and to Chief Executive Officer, Production Officer, they should understand that they are in the same boat, yeah, because if this message not crossed from the high level, you will fail, yeah, because you cannot explain to the business, to the high level, to the factory director why you need to spend weekend without the system, yeah. So from my point of view, first of all, this message should be crossed on the high level. They should agree, and we need to, let's say, to get the confirmation that this message was crossed, and these people talk to each other. Yeah, and as soon as they talk to each other, we've got this confirmation. Then we can go to the level down and explain it, guys. Don't talk to me. Yeah. So if you not agree, you do not agree, you think that something should be done differently, talk to your boss, please. Yeah, this is the point.
Okay, so actually it wasn't a buy-in, so you told them that there is no other choice, because the IT strategy is to move everything to the cloud, and actually there is no option not to move and not to migrate.
Yes, I would say yes, but you can let's say turn it as you want. You can say that it's buy-in by the high-level guys.
Mm-hmm.
Yeah? So.
Yeah, but there's like a lot of communication channels, and I think the communication was prepared on the various levels with explaining the strategy, why actually we are doing that. So not that, okay, the moment you understand the strategy, then you don't question anymore, the particular implications. But it has to be linked to something that, there are various benefits overall for the company that are critical.
Clear. Thank you.
All right, I think those first, all right?
Okay, so thank you very much for all of those experiences, the awesome experiences shared by you. That was really helpful. So my questions are really AWS specific, because when you were sharing the strategies, while how did you move to AWS and you actually chose the AWS specific AWS services. So there are 2 points. So my first question is like, are you actually, are you using any containerized solution within your services? And the second thing is, how did you actually handle the licensing part of the application or the SAP? Did you actually specifically choose any kind of specific instances or hardware model or anything?
So for SAP, okay, so regarding containerized workloads, I think for the SAP, we don't have any, if I remember correctly. I would maybe need to cross-check that, but I think maybe, if anything, just some minor things. But really, for any of the major components of the landscape, there is no containers at all. So that's the first part of the question. Second part, in terms of the SAP licensing, I think SAP license agreement that we have, at least, does not prevent from the cloud workloads. So that was absolutely okay. Microsoft, I explained, there are limitations that you need to, let's say, adhere to. Yeah, we've just followed those limitations. But SAP-wise, I think the level of enterprise agreement that we have with SAP was not really restricting any workloads on the AWS.
Okay, so I mean, you did not have to choose any kind of specific tenancy in AWS? No. Okay, thank you very much.
Thank you. And the next question.
Yeah, 3 questions, but quick one. First, during this exercise, because it's live and shift exercise, but have you had chance to use anything from AWS, like for the observability, monitoring? I saw only S3, if I could remember. I'm not sure if during that exercise you were able to use any AWS services, or you had to move all of the things to as it is right now. Second question, could you elaborate a bit more about the latency after the migration to the different data center? Mm-hmm. If it ends through the VPN direct connection, or all of the traffic were put to the public infrastructure. And the third thing, question about the legacy stuff and surprises that something was working on the on-prem, but AWS support in a different way, in different kernel version, library version, or issue with the protocol, something that was not obvious at the beginning.
Okay, so maybe from the back, I don't recall any such problem. Actually, as part of the migration, we were switching as well, or upgrading the Windows and SQL, as we had the versions were running out of maintenance end of last year, if I remember correctly. So we had to upgrade them as well. So that was at the same time as the migration itself. And I think we did not really face any of this type of issues or incompatibilities. Regarding the observability, basically we are following our deep standards of this platform. I think Piotr would be able to actually tell a bit more which exactly components we are using for the observability. Some of them are AWS specific, but we are also feeding some solutions which are not deployed on AWS, but not AWS services. And on top of that, specifically for SAP, we are still using the Solution Manager for certain aspects of the observability. So that's a solution which we are still using for various reasons. One of them is to get the proper support from SAP. You actually need to use it, so that you have your early watch alerts and various other metrics that you can collect in Solution Manager. So that we have not changed. What was the
latency?
Latency. So basically, for the system-to-system connections, we are using the Direct Connect. And for the end users, over time, we were actually switching to Global Protect, which is, I don't remember, like a VPN type of connectivity, but over the public internet. Before, we were still relying on the Direct Connect. So for the first, I think, 2 systems, as the Global Protect was not deployed yet for all the end users. For example, the on-prem users, naturally you are connecting through the PMI network and the Direct Connect to AWS. For the remote users, we were switching from the VPN to the PMI on-prem, which was then going through the Direct Connect. We were switching to this Global Protect, which was going through the public internet. And the latency, I think the increase was in the ranges of 50 milliseconds, if I remember, 50, 60 milliseconds in increase, which for the end users were more or less, let's say, cut down by the increase on the database times, the application processing times, etc. So that we, at the end of the day, were able to keep it equal or even improve the response times for the end users. And for the system-to-system connectivity, most of the cases we have not really seen a negative impact. I think the biggest was one of the latest migrations, which was this IMDL solution, the identity management, which is integrating with the Active Directory. And then this one is a bit suffering, so we had to actually, it's simply because there's thousands of processing done every new employee, every change in the role that is assigned to employee, which, you know, for 70,000 employees, it's like a lot of requests flowing. So we have actually deployed additional application servers just to cope with this extra workload, or let's say longer processing time that coming out of that. But any other solution, I don't recall major problems with the interfaces due to latency.
Maybe I can add a couple of points here because it's quite interesting point. So I do remember that in our first migration, we had to update sub-GUI to the highest version, 7.6, just to be sure that login is going smoothly, because on the oldest version it was not that good. Yeah, first of all, and the second one, which is not related to latency, but can be considered by the users like latency on the factories, I would say. When you up and running the system, you have a huge queue of iDocs, which already generated when the system was down. And it took, for big factories, it took about half of the day or maybe 1 day to process this iDocs that were already in the queue. This can be considered by the end users like something wrong with the system or with the latency. Yeah. Yeah.
Okay, thanks.
Thank you. Wow, so many questions. Perfect. So let's start here.
I have 4 or 5 questions. I'll start with first.
So maybe I answer one by one because I forget.
So when you initially started this migration, what was like, expected or planned time for the migration, and the actual time we saw that it's around 2 years. So what was the expected migration time, planned time?
For the whole program, yeah, we assume 2 years.
Okay.
Plus, let's say this POC time, which was like 3-4 months in advance.
Okay.
So we had to it actually took longer, the POC.
Yeah.
So we started a bit late, like 2-3 months late, but we were still able to keep this final deadline. At the end of the day, we delayed by 3 months, but that was on the business request, not due to the program itself.
Okay, thank you. The next question is about the integrations. So you mentioned there were around 20,000 integrations, and it has to be done one environment after another. So were there any automation that was added for the integration testing, or it was all manual?
No, I mean, unfortunately not. I would say majority of the testing is for us. I mean, we have some automated testing, but it's mostly to cover regression and business processes, but really not on the integration. So really integration was done, let's say, part of the UAT or kind of connectivity testing, which was mostly manual.
Okay. Now, coming to the actual migration, so you mentioned there was one system around 18 terabytes. So when considering that one of your system, what was the highest database size for one of the system, and how much time it took, and was business ready for that downtime?
Mm-hmm. So yeah, the biggest was 18 terabytes, single database. And regardless of the size, we had this pre-agreed window of 48 hours, I think for the HR solution, we agreed longer window because of some specific integrations. I think I agreed on 60 hours, if I remember correctly. But to achieve that, you would not be able to migrate it during the downtime window. So for that, we actually use pretty basic technique, which is to migrate the full database backup, which we took like on Wednesday, migrated it over the next 12 or so hours. And then during the downtime window, only take the differential backup to cover those last few days, which was like already much faster.
Any reason for not using any services from Snow family?
Basically, we found that basic tools work. So why do you go to? Yeah, I mean, I personally have experience with like tools from SAP, which is like zero downtime migrations, but there was simply no need for that. So typically, that will be additional complexity in the program. So if you know the basic backup restore works, why would you invest in additional tools for that?
Okay, thank you. That's it.
Okay, thanks for the questions. So let's move forward.
A question from me that was similar asked. You said that the driving force behind the migration was the strategy, but you also said that you didn't. You said to the business that they won't benefit basically from the migration. And at the same time, you migrated because of the strategy. So what is the driving force behind the strategy going to the cloud? Because going to the cloud on its own can be a strategy, but what's the driving force behind it?
Look, I mean, the key aspect of that, especially if you think about managing your own data centers and your infrastructure, was really to release the workforce from doing this type of activities, which we find not really key or value added in terms of the business perspective. So we really wanted to make sure to let's say, switch internal, especially internal workforce, but also resources that are, taking care of managing your infrastructure, managing, the operating systems, etc. Shifted to AWS, to our cloud partner, take it as a service, and then you can actually reposition the PMI employees and a lot of contractors to do more value-added stuff. I think that's probably the key driving force really on this cloud strategy. Piotr is nodding. We're not sure if you want to add something. All right.
There is one more reason behind. So it's one was to release the resources and focus on the more modern technology and really engage people to build the new solutions, cloud native solutions, because this is I think the strategy not only for PMI, but for the whole world right now, and the IT, if you would like to be IT-driven company. But the second topic is which you can compare to your personal belongings most. So if you need to relocate, if you need to sell your house and move to new place, you probably will do some cleanup. You will not take everything like a hamster, and you will reduce the amount of things which you transfer, and also it will allows you, in case of business, reduce the cost. So we started with the assessment for the whole program. So it's not only SAP. Around 2,000 applications which we are maintaining in PMI for the business, and we decide only to migrate 600. And the rest we decide to either switch off in the meantime, or replace, or rebuild, but keep this small amount. So reducing the amount of application also in the future allows you to save the money and resources. Yeah, so the question was that we were like considering this fact, and we are dropping some legacy systems. Imagine if you have such big company, like 70,000 people and a lot of factories, a lot of entities built all small solutions. which you need to maintain, which you need to deliver the specific technology. And when you are migrating, you can consolidate and replace, I don't know, dozens of systems with one and do some adjustments. And if you will not like force this change, it will never happen. And question. I will use the opportunity. Did you receive like good support from AWS in case of migration, during the migration?
Actually, maybe I didn't mention that part of the core team was also AWS, and there were, I think, two critical aspects of that. One is that first of all we had an experienced architect with us who has both AWS and SAP expertise, and that was really key, both in terms of his personal involvement in the project, and especially at the very early stage for the architectures, but also to link back to the various, back office of AWS in case of some major questions or problems. That was definitely a critical aspect. Another thing, I think it was mentioned on the slide, but we didn't voice it over so much. One of the key stakeholders which we had was the senior leadership from PMI and from AWS. So we had like an executive from AWS on a monthly basis. We were really governing, let's say, the transition for SAP specifically. So yeah, from the very beginning, we thought that SAP is like we call it crown jewels, moving from one place to another, so to make sure that there is no disruption and the proper attention from both sides is given to the program. So yes, we were definitely happy with the support from AWS. And also, we are on the way. We also noticed a few times that there were capabilities built by AWS, not specifically on the request for PMI, most likely, but things were evolving. So there were at least twice things that were at the beginning we didn't have. By the time we were migrating our first production systems, we were able to benefit from new features, new capabilities, which were quite essential for our migration.
And I should also admit that our AWS representative, our team member, was involved in our daily stand-ups. Yeah, so everything what we were doing, it was shared between us, AWS, IBM, so on daily basis. So of course we've got all required support. Yeah.
Okay, thanks.
Thank you. Any other question? Oh, we are.
Yes, some more questions. I think there was your first.
Thank you. No one asked about the money. Yeah, and from the cost-saving perspective, this kind of migration, does it make sense? Maybe in persons, you have some numbers.
I don't have numbers. I think I tried to explain it last slide. It's really more expensive than you think when you start running those workloads, especially for such big and complex systems. But there's also ways of saving later on. In the times of this type of lift and shift and very tight schedule for the whole migration, you probably don't have enough time to really do the very, very detailed analysis of your workloads, or you want to be on a safe side, so a bit oversize your instances, but then it's good to really review that, like shortly after go live, maybe after, for us, the quarterly closing or monthly closing periods are quite important because the workload on the systems increases quite significantly, but it's important to review that, downsize, and also stay up to date because AWS is constantly introducing new instance types. In SAP specifically, or let's say combination of SAP and Microsoft SQL, you can save quite a lot of money by simply implementing or switching to the new instance types, which have more powerful CPUs. So therefore, you can, and you have the license model for SQL is CPU based or core based, so you can save quite significant amount of money. So that's something like a constant process afterwards. But I can't really, I don't even know, what is the comparison of the TCO before and after. So can't judge. But yeah, high level, I would say, yeah, be careful because it might end up a bit costly if you don't watch out. Also for the things like, this good or bad practices that I mentioned earlier.
Thank you. And one more question, if I can. this is a huge change to the business, right? And I think some of your business users remain unhappy because of this migration. Who are these users and why they unhappy after migration?
You want to pick up this question? Yes and no. Because for the business users, actually, it's nothing happened. Yeah, because they did login in SAP system, and they start to do the login in the same SAP system after the AWS migration. If you did it rightly, if it's you follow the rules, actually they even did know that it's on AWS. Yeah. So from our point of view, again, as I already mentioned, the main point from the first migration that we had an issue with SAP GUI, and some portion of people who have had older version of SAP GUI, they had an issue with LoRaWAN, but it was solved quite easily. And a group of people on factory flow, they were not happy because they was thinking that as soon as the system up and running, everything works perfectly, but they have to wait till the iDocs, the queue of iDocs will be processed. This is mostly what I remember about the AWS migration. Because actually for business users, they even, let's say, not that interested in AWS or on-prem. So for them, just, give me my system, and I would like to be sure that it works like it worked. Yeah?
And maybe if I can add, yeah, I mean, you can't avoid to have any impact on the business. But I think what worked really well was the established communication channels and the way we were supporting them in case there were some incidents happening. So by really addressing that quickly with the direct communication to the business stakeholders who were actually impacted by those, let's say, a few incidents, that really helped as well to maintain, let's say, the good relationship at the end. They were even, thanking us to solve issues quickly. Because I think, yeah, they also understand that you can't really have zero problems afterwards.
Thank you very much. The time, unfortunately, is running. The Andrzej is waiting for us. But thank you very much, Adam, for this presentation. Vlad, pleasure. I'm always happy to hear that we have. We have amazing IT project that nobody noticed. It's usually the biggest success when you have migration and nobody noticed that. So congratulations, guys. That's what is happening in Krakow, on our premises. If you want to join those guys, that guy there sitting, he can talk with you. I think it's important to understand that a lot of awesome things regarding technology happening in our neighborhood. So you don't need to look around, travel, or everything. You just have the heroes at the corner. Guys, what I want to tell before we jump to Andrzej, who is connecting to us from AWS, from Poznań, I think from Poznań. So, AWS Community Day, we have a free meeting that it will happen in Warsaw on the 1st of June. Yeah, June, exactly. The 1st of June. Already registered 400 people. We'll do it on PGA National, so on our stadium, National Stadium in Warsaw. So it's a pretty big event. Of course, our long-time lasting partner PMI will be there. So I'm very happy to have you there, guys. And feel invited. The only thing that you need to do is go to Warsaw, have an awesome day, like entire day about technology. We had 67 call for papers, guys who wants to speak there. We took only 30, so half of it. So there is a really mature, really good technical content there. Yeah, feel invited. So that's the one thing. And the second thing, which is important, I just want to show you, because as usual, we have a quiz, guys. So if you were able to jump in, we have some vouchers, $50 vouchers for AWS. Don't think about, okay, this way. Don't think about Amazon. It's not Amazon vouchers, okay? So you will not be able to buy yourself a socks or a pillow with a Nick Cave, right? But you can buy some workouts. at least. So for $50, go for it. Some questions regarding our meeting today and generally about AWS. Go for it. We'll choose the people on the end of the meeting. And Maria Andrzej is there? All right, cool. All right, perfect. Perfect. So yeah, let's move on.
Hi, hello. Can you guys just let me know if you can hear me okay? And can we switch the StreamYard view to the actual presentation as well? Hey. Can you hear me now okay? One, two, three, testing, testing, testing. Can you guys hear me okay? Maria, can you let me know in the chat if I'm audible now? So we can go ahead. It's kind of freaky doing that remotely. I cannot see or hear anyone. Is that any better? Okay. Okay, so let me know when you guys set up the audio. All right, 1, 2, 3, testing, testing. 1, 2, 3, testing, testing. AWS, IoT, AWS, IoT, testing, testing, testing. Now it's fine. Great. All right. So can you just ping me on chat? Is it okay for me to start? Again, I cannot see or hear anyone, so make sure. All right, cool. Thanks for the confirmation. Hey, hello everyone. My name is 𝐿ę𝐝𝐳𝐲𝐦𝐿𝐝𝐻𝐻. I'm a senior solution architect for IoT in AWS, and today we're going to speak a little bit about IoT, and specifically, I wanted to kind of give you a brief introduction into the technology called LoRaWAN. And first of all, huge apologies for actually doing that remotely in such a manner. I was kind of defeated by the logistics of connections between the Poznań and Krakow. So if you guys want to would like to have me again, invite me again, I'm more than happy to actually be there in person, because nothing actually compares to being in person, the meetups like that, instead of being just this voice from the computer that I'm in right now. But it is what it is. So without further ado, if you have no experience with IoT whatsoever, I think after the presentation, my hope is that you have at least kind of remember what LoRaWAN is and actually what it does. If you have any experience or exposure in IoT in the past, you probably heard about LoRaWAN a little bit as well. And in that presentation, I'll give you a quick run through the actual technology, the kind of basics of how it operates, how we actually implemented that technology in the AWS IoT services landscape. And also at the end, I'm going to show you one of the kind of use case prototypes examples when you can kind of see how this actual technology kind of brings everything to life, and actually what you can do and build and help with using that connectivity solution. So pretty much let's start from like the very textbook operational kind of textbook definition, right? So LoRaWAN, according to this LoRa Alliance definition, is a low power wide area networking protocol designed to wirelessly connect battery operated things to the internet. And if you don't know what LoRa Alliance is, pretty much everything that is concerning LoRaWAN as a specification, as a standard, that is the alliance that actually keeps the versioning of the different specifications, and then decide what is the actual specification of the next version of the LoRaWAN protocol as well. So they are, so to speak, like gatekeepers of that specific protocol. There are multiple versions of LoRaWAN protocols, but we're not going to go into very technical details with this presentation in terms of differences between them. But basically, that's it. That's a radio transmission protocol that is long range and low power, and it's pretty much specifically designed to operate and work within the IoT space. So obviously you can say, yeah, but we already have tons of different connectivity options, right? And you will be absolutely right. We currently have many of those technologies. If you look at the right slide, probably those are the one of the, you will see maybe like 4 of the most common ones. So you have Bluetooth Low Energy, you have wireless, you have obviously cellular, and on the bottom you have LoRa. And as you quickly see on the diagram, there's always a trade-off in terms of radio frequency, radio technologies, right? You always kind of sacrifice data rate for range, or the other way around. And the more data rate you actually require for transmitting the data, the shorter your distance will be, right? Think about your wireless network at home, and how many times, if you have quite a big home or you need to extend it to your garden or something, you absolutely need to actually put something additionally to this wireless network to actually extend the signal even more. But it gives you a huge data rate, right? And LoRaWAN, if you see on the slide here on the right in this diagram, it is a pretty low data rate protocol, but it gives you a very long distance to work with, and that's why that's pretty much what it makes a very good applications for the IoT devices, because a lot of the IoT devices actually don't have to send a lot of data very frequently, and in those cases, LoRaWAN is a perfect fit. And if you add to the fact that maybe most of those devices are battery operated and are kind of deployed independently somewhere out in the field, and LoRa is a very, I would even say extremely low energy consuming protocol. Again, it is a perfect fit for those kind of IoT applications. So long range and long battery life. If you want to go slightly more technical, this slide at least aims to explain what is the actual LoRaWAN technology stack. What are the different building blocks of the LoRaWAN of the LoRaWAN technology stack? And as with any technology stack, you always start on the physical layer, right? So on the actual bottom of the physical layer, obviously we're talking about radio. So we need some kind of a radio frequency to transmit the data over. And depends on where you are in the world, there are multiple different frequencies that are freely available and unlicensed that LoRa is actually using. And those are, for example, in Europe, it's mostly 868 megahertz, pretty much. In Australia, it's slightly different. Asia as well. US have a different frequency as well that works with LoRaWAN. And here's a small caveat. There's already ongoing works to introduce additional frequency, which is 2.4 gigahertz actually, frequency to the LoRaWAN technology, but it still kind of is in progress. Technically, it's already there. You can actually find 2.4 gigahertz LoRaWAN chips. However, they are not considered as a LoRaWAN compliant because the LoRa Alliance still requires some additional certification to it. But 2.4 gigahertz is pretty much, for LoRaWAN, it's pretty much reality right now. It gives you obviously a way higher data rate because of the high frequency, slightly shorter distance of the transmission because of that high data rate. But that's a caveat. Basically, you operate on those frequencies that you see on the slide right now. On top of that radio modulation, that transmission, on top of the frequency on which you transmit the data, you obviously need to have a radio modulation. And the modulation is called LoRa, and that's also one of the confusing things when it comes to LoRaWAN. It's a lot of confusion between what is LoRa and what is LoRaWAN, and this is the actual difference. LoRa is the name of the radio modulation that is pretty much a licensed and closed license modulation, patented technology by companies called Semtech. So only Semtech as a company actually produces LoRa chips, and that is basically the modulation definition, LoRa. And LoRaWAN is actually the whole protocol that uses the LoRa modulation, the LoRa modulation for data transmission within the physical layer of that technology stack. That is kind of the main difference. Once we're done with the LoRa modulation, we go up to the stack, and we have now the actual beginning of the LoRaWAN protocol. And the LoRaWAN protocol defines 3 different classes of devices. We're actually going to dive deep slightly into the next slides. What are the differences between those class A and B and C of devices? But basically, at this point, 3 different classes of devices. They differ how they operate. That's the main difference. On top of that, within the LoRaWAN stack, you have a LoRaWAN MAC. This is basically a layer that exposes different configuration items you can tweak from the application layer that you are running actually on the LoRaWAN device. So there are multiple commands that you can issue from the application to the actual LoRaWAN protocol through those MAC commands that will change how those devices are operating, how they are behaving in certain specific aspects. And obviously on top of every technology stack, in that sense at least, there's your custom application that runs either on any kind of LoRaWAN compliance device. Most of the times, those devices in terms of hardware are actually microcontrollers that are running those, but nothing stopping you from having a Raspberry Pi head with LoRaWAN head on top of it. Will absolutely work the same way. You can actually build the LoRaWAN gateway very, very quickly with the Raspberry Pi as well. But this is basically the technology stack of the LoRaWAN, right? So you can now ask yourself, okay, so why I actually need it? What problem does it solve for me? Well, it's pretty useful technology in multiple different areas and industries. In equipment monitoring and predictive maintenance, when you have a pretty big, pretty sizable and quite big area to cover with sensors, and you don't have wireless everywhere, and you don't want to pay, for example, for cellular SIM cards for every sensor you put out there, and then basically LoRa is your perfect fit. For any kind of asset tracking and monitoring, when you, for example, need to track something and send the GPS coordinate to the cloud, but not every 2 seconds, but let's say every 60 minutes, once a day, that's a perfect application as well. And also obviously, and that's connected buildings and city systems, and that's from my experience so far when I work with multiple clients of AWS within IoT space. That's the part of the actual use cases that are exponentially growing right now that I see within last 2 years. connected buildings and city systems are really heavily investing in that technology as well, with new products being launched, and they are communicating through the LoRaWAN protocol as well. So as I mentioned, many use cases that you can support from LoRaWAN, right? So starting again from the long range, through long battery life, it's very cheap to build LoRaWAN device. Actually, the chips, despite the fact that the LoRa modulation is owned 100% by Semtech as a company, the chips that Semtech produces are very, very cheap and very easy to build on. There's actually an entire ecosystem of other partners and vendors that are adapting Semtech bare-bone LoRaWAN chips, and they're building kind of their own silicon solutions on top of it. And that's even a better solution, especially when you are into like tinkering, kind of making things stuff. It's a huge and very, very, very friendly ecosystem, and very, very cheap again. And also LoRaWAN gives you a secure standard. Pretty much all the transmission within the LoRaWAN protocol are encrypted, and that encryption is obviously within the bidirectional communication as well. And as I mentioned, this standard of LoRaWAN security is then dictated and kind of gate kept by the LoRa Alliance. And we are talking about the range, just to kind of, I just throw in that slide just to give you something interesting actually to see within LoRaWAN as well, is that the world range record for LoRaWAN distance is 832 kilometers. I think it was established maybe one and a half year ago. The way they did it is they actually attached the LoRaWAN device that was battery powered to that balloon on the left, and they basically filled the balloon, I think it even with helium or something like that. So it went up very, very high, very, very quickly. And then when you can see on the map in the middle, it kind of traveled a little bit on multiple altitudes. And first, actually, they catch the transmission, that device, they catch the data that the device was transmitting from the balloon. I think in some kind of middle of France or something like that. And the guys, they did it, they actually said, oh my God, that's so far away. It's like hundreds and hundreds of kilometers away. And then after an hour or 1.5 hours, something like that, the tower, which is pretty much at the border of Czech Republic and Slovakia, actually picked up that signal as well. And that was actually, till now, is the world record for the LoRaWAN range in terms of data transmission. So 832 kilometers. Obviously, that was only for a test and only for the record. Nobody is going to actually launch the balloons and send the signals for everyone. But that is also the cool fact, just to kind of illustrate how long can actually LoRaWAN transmit the data. It's extremely long range and again, and a very long power. So quick dive into the architecture of the LoRaWAN. So if you would like to build your own network at home or somewhere on premise, or pretty much establish a full control over the devices, gateways, and also run your own network as well, you need to be aware that it's not only LoRaWAN devices that are sending data that you see on the left. It's not always only the gateways that are catching this radio data and backhauling that through the IP protocol to your servers. It's also 3 servers that are basically working in unison to kind of serve, protect, and transmit the data between the network and the backhaul application as well. So you have a network server, you have application server, and you have joint server as well. Actually, joining to the network for each LoRaWAN device is quite a complicated operation. So there's a dedicated joint server actually running only for joining. Obviously, network server is responsible for trafficking pretty much all the communication between the gateways, nodes, and other servers. And the application service is responsible solely for processing the payload and the data that the devices are sending through the gateways to your LoRaWAN network. So if you want to build it yourself, it's pretty much 3 servers. Obviously, all the communication is secured and encrypted between each of those parts of the architecture, but that's basically 3 servers that you need to launch and run. If you would like to, for example, build a product that utilizes some kind of a sensors or anything like that is transmitting through the LoRaWAN, and you want to have your gateways, and then you want to have full control over what is being done over that network. That's pretty much 3 servers that you need to run. In IoT Core in AWS, we always try to simplify as much as possible, and LoRaWAN on AWS, it's no different. So basically, if you would like to build your own private network over which you have full control of, you just provision gateways and end devices from LoRaWAN into the IoT core. There's actually a menu item in the AWS console under IoT core called LP1. If you click it, you will see all the bits and pieces and options that are actually responsible for the LoRaWAN as well. So you just basically provision the gateways and provision the end devices. You can do it through the console. You can do it through the API calls. You can do it through the CLI as well. And once you have those provisioned into IoT core, pretty much right out of the gate, you will see in the IoT core console that the data is being sent. Then you basically just define what is the destination of the data. And in most of the cases, that's also specific to the LoRaWAN protocol. The data that you're going to see on the cloud side coming from LoRaWAN, the actual payload of the data that, whatever devices are sending, is it the temperature sensor, light, anything? It's basically an encoded payload. And that happens because the payload, we always try to have as small as possible. Because the longer the payload is, the longer time it takes to actually transmit the data. And if you want to really save battery, you basically just, in LoRaWAN, you just basically, the data payload is a base 64 encoded hex digits. And once you get that raw encoded payload from the IoT core, in most of the production use cases, you're going to basically just forward this traffic to the Lambda function that is going to grab that encoded payload and is actually going to decode it into something useful, right? So normally you will have the base 64 string, and whatever LoRaWAN sensor or device you're going to buy, you're going to have in the documentation or instruction, there will be a guide what bits and pieces, what specific hex number in the payload once decoded actually means, right? So that really allows for the very, very small payloads and transmitting a lot of different data without any specific overhead. But the price that you pay for that is the fact that you're not going to see the actual nice looking JSON on the console. You are going to see the payload that is basically base 64 encoded, and then you need to turn you need to forward this traffic to the decoder. And then obviously once you have it decoded from the Lambda, you can pretty much do anything you like with it. You can throw it to any kind of downstream services, DynamoDB, you can trigger any other Lambda, send it directly to application, anything you like. That's your data that you have from the sensors. And again, this communication is bidirectional, right? So it's not only LoRaWAN devices sending some data to the cloud. You can send some comment or some actions or something back, some kind of information back to the devices as well. And now let's quickly go through the device classes. So if you remember the previous slide, when we talk about the technology stack, there was LoRaWAN that was dictating a classes, and it was kind of describing class A, B, and C. So now let's quickly actually see what that means. Class A device. So I would say that if you ever encounter or anytime and anywhere have in your hand LoRaWAN device so far, there's probably 90% chance that this was a device class A from LoRaWAN. That's the basic class that is defined for LoRaWAN. It guarantees the lowest power consumption. And that's because that most of the time the devices are actually in the sleep mode to preserve the power. They only wake up, gather the data from the sensors, and they send the data to LoRaWAN network, and they go to sleep again. And you want to have that data sending uplinking frequency pretty much tuned down to the minimum, because every time the device wakes up, it causes the battery to be drained, right? So it is the lowest power consumption actually class from all of them. You can send uplink, which actually means like you can send data from this device to the cloud pretty much at any time. And if you want to also accept some data to this device from the cloud via LoRaWAN network, then you first need to send uplink. And then after the uplink, you will have two receive windows open on the device, waiting for some data coming back if you actually want to send something back. So it requires uplink to receive downlink. Obviously, it's a high latency device class and most energy efficient. And that's pretty much, if you want to illustrate, that's how the class A devices in LoRaWAN actually work. So that's the gateway that is accepting the LoRa radio modulation, and that's the end device. So this device wakes up, it gathers the data, sends the data up, and then it and the two RX1 and RX2 delays, those you can actually configure as well within your application. But after the uplink is going to wait a specific period of time, then it's going to open a downlink window. So it's going to open the downlink window and basically say, hey, do you have anything for me or not? If it's going to be no response, then it's going to open another window again, say, well, are you sure you don't have anything for me? And then if nothing actually arrives, then the device comes back to sleep. And that kind of repeats endlessly for the Class A devices. And as I mentioned, most use cases for the Class A devices, sensors, meters, pretty much anything around, again, I'm going to come back to the smart city example, right? So we have a number of really, really big metropolitan cities that are utilizing LoRaWAN protocol to gather the data from multiple different infrastructure points. We have quite sizable customers that are actually using LoRaWAN to read the data from the energy meters, from water meters, and things like that. It really is simplifying a lot of their operation. And those devices are so small that you can actually fit them anywhere, and the range is huge. And obviously, you don't need to read your power meter every 5 seconds. So polling every 2 days is even more than enough. So with the proper battery put into that meter, it can last for years as well. And the same for those little black sensors I have on the slide in here as well in the middle. Those are actually coming from a company called 𝓥𝓵𝓏𝐼, a really cool company that is producing out-of-the-box LoRaWAN devices that are pretty on the budget side in terms of cost. So there are multiple of them as well, like nose sensor. This is like soil moisture sensor. This is the vibration sensor, the temperature sensors, and all of that. But basically, Class A, it's mostly sensors and meters. Everything that kind of sends data pretty much goes to sleep. And then let's move to Class B. So Class B, the only difference pretty much between Class B and Class A is that Class B will open the downlink windows more frequently. So it enables actually to pre-configure downlink time windows, and you configure that on the end device as well. You don't have to send an uplink from the device to actually receive any kind of a downlink back from the cloud, right? So you don't have to send first to receive. With Class B, it will constantly open the downlink windows on the scheduled intervals. Obviously, because the downlink windows is open more frequently, it's going to cost you more power and more time on the air, which also costs a lot as well. It has slightly lower latency, and also it supports Class A and Class B MAC commands. So what I mentioned previously, any kind of LoRaWAN specific commands, Class B devices obviously do support as well. This slide is fairly busy, and I see just the StreamYard actually does a horrible job formatting the slide. But basically, that's the main difference from the Class B, and I think also it's a little bit more complicated than it have to be. But basically, after every uplink, you can see on the bottom on the end device, it's just the same as Class A. But after the second receive window, there's a beacon you can configure, and then between scheduled period of times, there's going to be like a ping command between the gateway and device just to synchronize time between those two. Because the time synchronization between gateway and device in that Class B class is very important, because you want to make sure that when the end device opens a downlink window, gateway will know that this is actually when it happens, right? So they need to ping each other, constantly be synchronized in terms of time. And between those pings, you can always open new downlink windows over and over again. So again, you don't need to have an uplink in order to have a downlink. So if you have any kind of use case with a problem like that, that's the Class B for you. And the Class C is, I would say, way simpler than Class B, to be honest. Again, it uses everything that Class A does. So it all, after every uplink, you're going to have two downlink windows to get some data back from the cloud. It have the lowest latency among all operating windows, and it have the constant downlink window open. And obviously, because of that, it uses way more power than all the other device classes as well. And because of that, mostly these Class C devices are being actually powered by some mains, by plug, by basically constant current instead of battery. They are not battery operated devices. And this is pretty much how it looks like, right? So you will have end device sending the uplink like Class A. It will also open those two downlink windows, but between those two downlink windows, he will always open additional downlink windows as well. So in other words, Class C device is constantly listening for the signal from your LoRaWAN network and from the cloud. And that makes it the perfect application for any kind of industrial automation, remote monitoring, again, smart cities, and actuators and bridges, right? So if you have anything in any kind of use case or product that the power efficiency is not really a problem for you, but you don't have any range, any wireless connection available, and you don't want to have a cellular kind of dependency on the SIM card or anything like that, that is the perfect solution, Class C, for the LoRaWAN device. You know, things like let's say remotely controlling the city lights, turning on and off, any kind of actuators, bridges, any of those devices like that. You can deploy it out in the field, and you can have, for example, in mid-sized city, you can have just a handful of gateways and a number of Class C devices, and basically then you can remotely turn on off lights during the night and during the day as well, whatever you want to, and also do other stuff, like, for example, this rack wireless device. This is basically a bridge between Modbus and LoRaWAN. So this rack 7431 device is actually gonna get the Modbus data if you are having any kind of manufacturing kind of industrial application, and will forward this data through the LoRaWAN as well. This device here called from 𝓥𝓵𝓘 is a very cool device, actually. If you want to experiment at all with LoRaWAN, that is the actual device I would really recommend, because you buy that device, and as a package it comes in with like 2 or 3 relays, so you can actually right off the gate you can kind of turn on and off things. You can hook up multiple different sensors to it as well, and it's going to accept the data and push it over to the cloud. So if you're keen to kind of start off with different device classes and learn about LoRaWAN, it's called Digital I/O Controller from 𝓥𝓵𝓘, LoRaWAN compliant. It's actually a Class A and a Class C device, depending on how you switch it. But it's a very versatile tool. I actually have I think 2 of them, and I rarely have a case where I cannot use that as a prototyping kind of solution in some kind of application as well. So highly recommend this one as well. So that's basically Class C, right? So anything that is pretty much, you know, requires you to be constantly listening for a signal coming from the cloud, so the device can take any action. That's the Class C. And the last thing about the device classes, because I don't want to really bore you to death with this, but one of the really cool things about LoRaWAN device classes is that the device class is actually being set up by software and not the hardware. And what that means is that during the actual runtime of your LoRaWAN device, you can switch between different classes. You can switch from A to B, from B to A, and from A to C without rebooting the device, without even kind of quitting, without doing any kind of major interruption to the device operation. Because again, the device class is being dictated by and set up by the software during the runtime, so you can flawlessly switch between those classes. And obviously you can have question, okay, so I know my device, why do I actually need to switch class, right? Well, there might be an occasion that this is actually helpful for you as well. For example, one of the cases is firmware update. Let's say you have a device that is very battery constrained, and you kind of wake up this device once a day. But if you want to update the firmware on that device remotely, first what you need to do is switch to the Class C, so it opens the downing window, and then you use that constant downing window to actually transmit the firmware file to the device. And once you have the firmware files to the device, you can actually switch back to the Class A, update, do the remote update procedure on the actual device, reboot device, and then resume the operation as a Class A device. But firmware update is one of the most classic cases when you actually switch to the Class C for LoRaWAN. And also one of the other things, like the conditional operations, right? Let's say you have a device that is required to get some data from the cloud during the day, but during the night it's not really required, and you also are battery constrained. Then you just basically switch to the Class A device for a specific period of time, and when the time is right, you actually switch back to the Class B or Class C as well. So any kind of conditional operations, especially when there's a power constraint involved in those devices, it's a really cool kind of feature of the LoRaWAN to do as well. And it's not only that you can kind of mix those classes during the one single device operation. You can actually build your entire LoRaWAN platform, or the solution, or a fleet of LoRaWAN devices that consists from like multiple different device classes at the same time, right? You can You can have any kind of application, for example, like this one, agricultural operation, when you will have class A, class B, and class C devices, all kind of working together and deliver the data to you, so you can actually make some sense of it and actually benefit from that as well. And many times when you speak about LoRaWAN, it's always something like agricultural applications and things like that, and smart cities, because again, it's a wide areas that you need to cover with range of your network, and then you build also at the same time you build your own network, so you don't actually pay cellular providers for SIM cards for it. You don't have to actually pay for wireless connection for each of the node, because you own the transmission, and you just basically it's pretty much free once you establish that. And no matter how much data you're going to push through the network, it's already there, so it's yours, and you're not having any kind of recurrent cost as well, which is a huge benefit for LoRaWAN on LoRaWAN applications as well. So again, you can build your platform from class A, B, C devices. They are all LoRaWAN devices, or they will all be provisioned nicely in the cloud. They will work as a part of one single big solution as well. So kind of moving on quickly from quite a long PowerPoint kind of thread. I want to end up with the real use case, and something that is, I think, is the reason why I'm actually here as well, because I met with a couple of guys from the user group when I was actually showing off the prototype at the reInvent last year. So one of the things that you can do with LoRaWAN is build a lot of different prototypes. And when you are into IoT and kind of been making stuff, you always kind of hear about some problems that you might actually build something and solve. And that's kind of that example. So my neighbor is actually a beekeeper, and he has like maybe 15 to 20 beehives. And we many times talks about bees that are all fascinating creatures, and I had no idea, about how fascinating they are before I actually met him and kind of really deep dive into it. They're absolutely amazing creatures. But he many times kind of, when it's Paul, he mentioned to me that a couple of the problems he has, and is there a way to actually solve that? Because hey, Andrzej, you're into computers, right? Maybe you can fix that. So problem number one, he doesn't actually know how productive the bees are without opening the beehive and looking into it. And that's something that you don't really, when you're keeping the bees, that's not something that you really want to do very, very often, because it upsets the bees, and they can even stop producing any kind of honey for like a couple of days if you do it. And it's also, if you have 15, 20 beehives and you need to do it, one by one every couple of days, it's a cumbersome task, and you have even more beehives than that. It's basically a job to see if it's full or not. And once you know how productive the bees are, you know when to empty the beehive. And also, the problem was the conditions monitoring inside the beehive itself as well. And it's not that, I kind of learned that it's not that important during the summertime, but it's very, very critical during the winter time, because it might be the time when the actual bees will eat all the honey during the winter that they actually preserve at the bottom, if I remember correctly, part of the beehive. And what that does, you actually need to supply them externally with some kind of syrup that is very, very sugar heavy, so they can actually survive the winter and kind of make it through to the next harvest as well. So I kind of thought about those problems, and I also thought that whatever I want to build is something that you can easily retrofit into the old beehives. I didn't want to build like new kind of a transformer, aka Frankenstein, full metal, kind of nicely high-tech beehive, because it's no value on that and it's not scalable at all. Something very simple, very, very cheap, and something that you can just patch onto the beehive and kind of forget about it. And that's the kind of the architecture I kind of came up with, right? So I had two sensors in each of the beehives. One is basically a digital scale, and the second sensor is basically a sensor that is inside the beehive that is checking the temperature and pressure, and the temperature, humidity inside, and also atmospheric pressure. Those sensors are connected to a little small microcontroller that is battery operated. And this controller is actually LoRaWAN enabled. So it sends through the gateway payload I believe, currently we are sending every 6 hours or something like that, the data through the gateway, through the IoT core, then it hits the IoT role that sends the data to the decoder, and then the payload decoder stores this actual data in the time stream database. And then I also am running the managed Grafana at AWS, and with configured data source as time stream database, and basically that we end up with a nice dashboard looking of the data for each individual beehive as well. It's a very, very kind of a simple architecture, very easy to deploy, super cheap actually to run as well, because pretty much all of that is serverless as well. And considering that I only have like one user, which is my neighbor, using the Grafana dashboard, is also, again, even cheaper to actually run Grafana as a managed service instead of kind of running your own on the EC2 as well. So that was the architecture bit. And this is actually how what I end up doing. And the project was pretty interesting, and I kind of describe it in a couple internal AWS kind of meetings. And we have an initiative within AWS called BuilderSphere. So if you are building something and you think it's interesting, you can kind of submit your project to the BuilderSphere, and if you get accepted, you actually get to reInvent, and you have 2 days at the reInvent main hall, exposing your product and kind of speaking with people, and they're curious. There's actually every year at the Euro event, there's a dedicated space for the BuilderSphere, and there's absolutely amazing things that you can see what people are able to build. So I can say that my project was the most low-tech project of all of them on the actual floor, but it kind of to my surprise, it really had a lot of interest as well. And again, hardware-wise, you can see it was the BME 280 sensor, which was pulling temperature, humidity, atmospheric pressure, and that was the digital scale. The scale, if you really look closely, the beehive on the table looks like it's slightly floating above the table because there is a weight between the table and the beehive. So the beehive actually stands on that scale. And to kind of add to the whole kind of do it yourself spirit, it's not some fancy scale. That's basically a scale that I kind of stole from my bathroom. I hacked it with addition of the HX711 amplifier, which is a very, very common application, and that allows me to actually read the data of the scale and interpret that in a kind of digital way. So my microcontroller is able to read it, and that was pretty much it. The little black box that you see at front of the beehive is the actual MCU with the antenna sticking out of it. Normally, I think right now we are running about 6 or 7 beehives with this setup, and that the actual MCU is hidden inside the beehive, but we kind of expose a lot of stuff just to kind of show people how it works. Also, we added a couple of improvements. So we added 2 solar panels, and we added the battery management system as well, and the battery pack below the actual, right under the hood of the beehive. So they are now fully independent from the power. They are running fully on battery, and they're also able to charge themselves if needed as well. So I was successfully able to run it throughout the entire winter when we tested how big the battery needs to be to kind of survive the winter when there's almost like no sun in a couple of the days, but it was running pretty fine. And again, very small amount of data we are sending very, very rarely. So the battery is more than enough in there as well. So this is kind of how it looks like. And that beehive also, just to add this dashboard for Grafana, this is the like 3 key data points. So the weight, the temperature, and the humidity as well. That beehive no longer, that they showed in the reInvent, no longer actually exists as a smart beehive. It actually was converted back to the dumb beehive, but it's there, and it's serving its purpose, and it's have bees in it, and and it's fine. But we're kind of moving into the slightly other upgraded version of it as well in the future. But that's just something I want to share with you guys and kind of show that it's not always about the architecture, diagrams, and LoRaWAN technology. You can actually have that technology, which is super cheap, and with a little bit of tinkering, you can figure out how to actually really solve some kind of real life problems. And you don't have to be a genius to actually do this. I mean, if I did it, anyone can do it. So I highly recommend for everyone to actually experiment with LoRaWAN technology and the data transmission. Those beehives are actually about 4 kilometers away from the gateway out there in the field, and more than fine in terms of data transmission. So it's a pretty cool project that kind of end up actually being kind of almost a product, at least to my neighbor as well. So that's my time. I'm hoping I didn't bore anyone to death with that PowerPoint presentation. Again, thanks so much for having me in. Again, apologies for dialing remotely, but it is what it is. Next time, probably we're going to do better. And if you want to get in touch, that's my email that you see on the PowerPoint. That's my QR code that you can actually scan that leads to my LinkedIn profile as well. And again, huge thanks for having me and for the time listening in.
Thank you very much. Guys, a little cheer for Andrzej and his work. Any questions? No questions.
How does it deal with disturbances?
No, yeah.
How does these devices deal with disturbances? You said that they that's the record, but that's the record that's up in the air between the tower receiver, which is, I guess, 200 meters high, and a balloon. But when it's in the city, you have buildings, you have other Wi-Fi signals, you have cellular phones, and so on. So how does it deal with it?
Yeah, so I think because of the frequency of the LoRaWAN transmission is so low comparing to most of the high frequency data transmissions that you mentioned, like wireless, for example, or the other stuff. The other data transmission is not such a problem in the dense urban areas. The only problem is the actual physical obstacles, right? So let's say you can have a range of about 20 kilometers even in a line of sight, which is, really, really nice, and that's like ideal conditions. But that within the city, it can get cut down into maybe 5 kilometers, maybe 3 kilometers as well. And it all depends what is the line of sight, how many obstacles you have on the way, how many buildings. And, God forbid you have a mountain in the middle. If you have any kind of ground, earth, actually, it's going to completely destroy the signal as well. So many times when you are trying to design such a solution, right? You always first find the higher possible ground for a gateway, and that is your gateway, and you put a really nice antenna on top of that gateway, and then you ensure that the line of sight is almost there if you get blocked for some kind of obstacle. But yeah, basically the biggest obstacle for LoRaWAN is the actual physical world, not the other data transmissions, and that's basically just the frequency is so low. Then it doesn't really interfere. But the buildings, bricks, earth, water is pretty much anything that kills the radio.
All right, thanks. And the question from the audience from the Void, Internet Void, Carolina here. Do you have any ideas for other use cases similar to this one as your next project? I'm curious.
Okay, no. Yeah, I'm actually building a new one for the next reInvent. I don't actually tell about what it is. It's not going to be high tech as well. I don't do high tech projects as well at all. But it's going to be something similar, and it's going to be also on LoRaWAN. And I'm kind of going to be doing a LoRaWAN version of that prototype, and I'm going to also do a Wi-Fi version of that prototype as well. So we can actually see in the real time when you play with it, what is the latency between Class C device and the wireless, and what is the delay when you, for example, switch something on. It's about a second of a delay. If you push the button on the application and you see something happening on the LoRaWAN Class C device, comparing to wireless, which is like instant, almost, right? So next project is coming in. It's almost at the stage of finalizing the architecture. I have a couple bits and pieces already physically with me. So yeah, I'm more than happy to kind of show up again. If it doesn't blow up, I'm more than happy to show you guys.
All right, thank you very much, Andrzej. And short notes, this was a funny story how I met Andrzej. So I was on the event and on the hall, and suddenly I see a guy with a beehive. I was like, the guy in the beehive, it's like not the place where you expect that, right? And I'm coming in, and it's like, hey, there's Andrzej there. And here he is. I hope you will join us next time on site, I hope in autumn somewhere. And you will be able to talk a little bit more about your new project. Thank you very much for that. Thank you for presentation, Andrzej. So the quiz time right now. So the last moments that you can, guys, win those vouchers. And Szymon, could you join me for in stage for a moment?
Definitely.
Yeah, perfect. Maria as well. Can you come for a moment? I think it's important for us. So life cycle of community It's all about sharing, right? This guy stay with us. How much time you stay with us? You know, like a leader.
4 years, few years. But I'm not sure how. Well, definitely 4 years.
Yeah. And I want you guys, if it's possible, to thank him a little bit for that, because he's stepping out of the service for some time from personal reasons. And Shimon, thank you very much for support. The group, I'm a representative, so thank you very much.
Thanks for giving me this opportunity.
We'll wait for you when you finish your business, right? And
I will rejoin.
All right.
No worries.
Perfect. All right. So what we have there? I think
we have quizzes, and if you didn't do that, please do it right now.
Yeah, and
but other thing is
So you need to choose. You know,
all right?
Because you was carrying the microphone. Who get the?
Yeah, I think we have few people.
Just drop
definitely here. I will go there basically. For the questions.
All right, thank you. Thank you for the questions. Thank you to react.
Applause, please.
Yes, a little bit. Applause of hate. You know, because you know how is it. You didn't get the package, so you can like lawfully hate person.
And definitely here.
Cool.
That was the one question, yes.
Okay, and the third one. This is a nice one. I like this one. And all of them the same, but I know what is this.
Do we have more people that ask question and they are not in the lobby?
They are not in the lobby. They are excluded. People in the lobby are excluded. They hear us. It's unbelievable. So now you can take it.
I will maybe pass it to the guys there, because I remember there was somebody asked the question.
Maria, I have a question for you. Do we tell people who win right now, or we will send the emails after the meeting? All right. Sure. Okay, to not fake it, then if you wait for a moment, I'll take from Maria who won, sorry. So let me go back there. Okay, $50, you know, it's big money. I think in this inflation, for $50 in Krakow, you will be able to get your tap water soon. Okay, so because of the RODO, I will not read the first one and the second one and the third one winner, because it's the name and the surname. I'm just kidding. So Pawełek, Wozik, and Robert Boguszewski. So 3 people will get the vouchers later on. Yeah, see you, buddy. He always wins, you know. He's coming.
And I just noticed one person that I missed, unfortunately, before, because he was standing in the shadow. Sorry for that. And we have the third winner as well.
All right. Thank you very much, guys. It was 64th meeting.
Exactly.
Yeah, 64th meeting. Thank you for your that you came here and be part of it. Hopefully we'll meet with some of you, or all of you, at the AWS Community Day in the next 2 or 3 weeks, basically. Yeah. And what can I say to the end? AWS User Group Krakow will return. Okay, thank you very much.
We'll be back. Thanks.